In the last 10 years, I have had quite a few successes with my business and my investments, but one thing I missed, and this was the NVDA stock. And in this talk, I will quickly go over the topic how I missed NVIDIA stock, even though I was uniquely positioned to see it. So, looking back the last 10 years, at the time of recording, it's 2024, like spring to summer 2024, and 10 years ago it was 2014. And I already saw NVIDIA stock, I saw its potential in 2014, but I didn't invest in it. Had I invested in it, I could have basically chilled out for a decade and do nothing and still outperformed me doing a lot of things, doing a lot of trades, doing a lot of investment decisions, doing business and all this kind of stuff. Okay, so let's have a look at some numbers and stats, some facts. Yeah. Let's look at the 10-year compound annual growth rate. So in the investment business, you don't look at the investment track record of, say, a couple of months or even a few years, like 2, 3, 4 years or 1 year track record. It has almost no information. But a 10-year record has quite a lot of information. So if you zoom out 10 years, a decade, and you have something that has a high compound annual growth rate, there's usually some truth to it, something they do differently, and where you can learn something. So if you meet somebody with a good track record, a good 10-year track record, then usually they have something. There is something you might want to think about replicating, right? And in this case, like I want to quickly give you some numbers here for comparison. So if you look at the stock market, it has a 10.5% compound annual growth rate. So let's have a look. So with things I have created this compound annual growth rate calculator. So say you invest $10,000 and you get like maybe say $100,000 back over a 10-year period, so you 10x your money in 10 years, then your compound annual growth rate would be 25%, right? So now what happens if you say only make 40,000, so you do a 4x in 10 years, then your compound annual growth rate would be 14%. Now let's make this 30,000. Now the compound annual growth rate is 11.6%. So still better than the stock market, right? The general stock market index. So let's try a couple of numbers. So for example here, something like this. So and here we are somewhere in the range of the S&P 500. So if you start with 10K and you invest 10K for 10 years in the in the S&P 500, you obtain 27K as a result with a 10.4 compound annual growth rate. So my personal portfolio, and this includes all of my activities I basically did. I started with a certain amount and I ended with a certain amount, which is now 10 years later. And my compound annual growth rate for my personal portfolio, so to say, is 50%. And this is including kind of some leverage opportunities, investment opportunities, also doing some like certain activities in business. And so if I start with 10,000 and I get say 500,000, just to have some round numbers, I would have had a 47% growth rate. Now let's make this 550. You see 49%, and this is like roughly the compound annual growth rate. So if you start with 10K and you invested at like 50% compound annual growth rate for 10 years, you get 550K. And of course, I didn't start in 2014 with a say huge net worth. I started like just from with my first job basically, and we will go over this over my timeline. But I had already saved up some money like through investment during my studies and saving and different jobs I have had since I was 14. Good. Okay, so this is like these are like the NVIDIA compound annual growth rate and my personal portfolio compound annual growth rate. And now if you look at NVIDIA compound annual growth rate. It was 68.9%. And this doesn't look doesn't look like a lot of difference compared to 50% compound annual growth rate, but this is because we underestimate exponentials. Now look, the initial 10K, if I would have started with 10K and put it into NVIDIA and then just did nothing the whole 10 years, how would I have performed in that case? So let's go back to the compound annual growth rate calculator. We start with 10K, and now let's make it 1 million. So if I go from 10K to 1 million in 10 years, I would have had a 58% compound annual growth rate. You see, it's only 8-9% more than previously, but the outcome is vastly different already. So these numbers, like even a small change in the percentage over time, can compound significantly, and this is because we don't really understand exponentials. And you see, even if I go to 1.5 million, I still don't reach the NVIDIA compound annual growth rate. So let's go to 1.9 million, and you see now we are like at 69% compound annual growth rate, which is what NVIDIA did. So 10K basically grew to 1.9 million in 10 years. So this would have outperformed me. So just investing in NVIDIA, instead of doing anything else, like writing thousands of articles, creating lots of content, doing lots of investment decisions, buying and selling stuff, and being very successful at it, right? I mean, my compound annual growth rate was pretty high. I would still have performed better just buying NVIDIA, buying and holding NVIDIA, which is like, I found pretty interesting. I find this like taking a step back and thinking about the big picture decisions. And of course, I mean, this is hindsight bias, right? But the thing is, I saw NVIDIA 10 years ago. I saw it clearly. I saw its value proposition clearly. I could easily have invested 10K into it at the point when I first encountered it. It was something I saw clearly. So it would be it was on my radar. And in this quick video, I want to like discuss or do a self-reflection analysis why I didn't do it. What were the reasons I didn't do it? So let's quickly have a look at my timeline. So in from 2007 to 2014 or so, I was studying computer science at university. I graduated with a with the best grade, best in my class, and got a PhD in distributed systems. And distributed systems, I focused on big data analytics. We will see this in a moment. So I was using NVIDIA GPUs for data analysis and AI problems. I had I had first class experience with using NVIDIA chips and GPUs. And I saw AI very early, right? I saw AI, and I did some great investments too. I invested in different AI plays over the last 10 years. That's why I have such a high compound annual growth rate, among other things. And so in this time, like between 2014 and 2019, I was doing my PhD in distributed systems. As I was doing the PhD, I was already building a side business, Finster. I was scaling up this my side business, Finster, and then gradually I put off the foot of the gas pedal and focused more on fun things. So I still do the business, but now I don't focus too much on my income or so. I focus mainly on investing in capital allocation and doing things I enjoy doing. And still, it hasn't hurt the income significantly, but it's just a different, higher profitability and higher fun business now. It's more like a lifestyle business now. And so these were the three big phases in my life. And for each of them, I will quickly give you my thought process why I rejected the NVIDIA investment. And maybe you can learn something out of it. So the goal with Finster is to help you stay on the right side of change. And we have had, with Finster collectively as a community, and also me personally, I have benefited tremendously from change. I have reached financial freedom by being on the right side of change, by basically focusing on the right areas and going all in these right areas. And but regarding the investment of NVIDIA at $4 to $7. So let's quickly check the current stock price of NVIDIA. So you can see the current stock price is like $877, right? So if you invested at $4 and now it's $800, you would have received a 200x on your initial investment, right? So investing 10K would result in 2 million or so. And here, this was basically in my first job. But actually, I saw NVIDIA even before, during my studies as a computer science student at university. Not even doing the PhD, but just being a student. I already used GPUs for AI-related data analysis and stuff. I was already investing as a student, and I could have seen NVIDIA even before for $4, but now like I just thought, okay, $4 it will be. I just use this number. NVIDIA was already like a big, well-known company. Many used it for gaming, and I specifically remember asking myself the question: Wall Street believes NVIDIA is a gaming company, but we're using GPUs for AI, and AI was already exploding in 2016. So I asked, could it be a great investment? I was interested in investment. I specifically asked the questions. This was like, if I had answered this question yes, it would be like my compound annual growth rate wouldn't be like 50%, but 69%, right? And at least because I would have still done other things that would be then just in addition to the initial investment. So I answered this question with, nah, the market is efficient. So I still believe in the efficient market hypothesis. And I thought, okay, there's nothing to do for me investing in individual stocks in the stock market. You can never beat the market, blah, blah, blah. All this like garbage you hear from investment advisors who are still working as employees, who are still not rich, but they advise other people to get rich, right? And you can see here my papers, like these are my published work, just to show you that I had the knowledge. I used NVIDIA chips. I was publishing papers about high-speed graph processing, distributed computing systems, TensorFlow, like Google's AI framework, deep learning, distributed computing systems, real-time data analytics, parallel systems, hypergraph partitioning, big data conference. I was publishing a paper like even on machine learning and stream learning. So dynamically learning or adapting machine learning models to include learning dynamically at runtime. I was also publishing a paper at ACM SIGMOD in 2018. So I was talking to all those people. I had seen like the conference topics shift from distributed systems focused research to AI focused research. So even in distributed systems, people were publishing more and more AI papers until I realized that more than half of the paper presentations I have attended used machine learning in their titles to publish papers. So machine learning was eating everything already within computer science. Every area in computer science was eaten gradually, was gobbled up, so to say, by machine learning algorithms. So machine learning was eating everything. I saw it very clearly. It was very obvious for me. Machine learning was eating everything in computer science, and ultimately it will eat everything in the real world as well, which is what we are currently seeing. But we are still in the very beginning phase of this transition, where machine learning like eats everything in the real world. So I was rejecting it because of the efficient market hypothesis. And I think this is a common reason people reject great investment decisions, because they are not confident. They don't believe in their own judgment. They think the market is efficient, the market is smarter than them, as them. They believe it's the best approach to, even though they know something very well, they are not confident enough to use their knowledge, because they think they are wrong, and or they convince themselves to be wrong. They have allowed other people to convince them that they are not able to predict market outcomes, which I think is very, very it's a very bad development we are seeing. So sometimes you have specific knowledge, and all you need to do as a human being is to use this specific knowledge, the specific advantages you have obtained through your career, through your specific experiences. You must use this knowledge in order to become successful. If you reject this knowledge because of some flawed efficient market hypothesis or something else, if you reject your specific advantages, you cannot become successful. So every success must rely on your specific knowledge. So you should, if you have specific knowledge like I had, you should use this knowledge to get an edge. At least you have an edge, right? Everybody has an edge one way or the other, right? Everybody has some specific strength, and we can only perform from our strength. And I think this is the biggest learning we can have from this whole talk. So we should have the balls, so to say, to use our own strengths, our given strengths, to use our specific advantages we have and not reject them, and not let other people tell us that these are not really advantages, or that the advantages are not there in the first place. Okay, so now the next phase, it would still be like a cool like 10-20x investment, like not a 200x, but still 10-20x investment, right? And this was like in the phase where NVIDIA was between $32 and $200. Remember, NVIDIA currently is like at $877, so still a great investment. I could have gobbled up a lot more. I also had a lot more capital now at this point, so I could have still invested in this. I had already seen the 10x rise of NVIDIA, right, from $4 to $40, and I thought, okay, it's I was right. The thesis was right. I didn't use it, so I was right in a way on NVIDIA, but I was wrong on the efficient market hypothesis. So I was starting to reject the efficient market hypothesis and using more and more of my strengths. Also, like creating my own business helped in getting confidence and trust in my own strength, because I needed to, right? If you are out there on your own creating a business, you need to work from your strengths or you will get eaten alive. So I was focusing more and more on my strengths. I was considering it. I had money to invest, even more and more money to invest, but I was rejecting it because of the following like thought process. NVIDIA is obviously winning. I was early in seeing it. It played out as I predicted. Should I still invest now that it has made its 10x move? So I rejected it. Nah, it's already overvalued. Right? This is like now I was not arguing from an efficient market hypothesis, because the efficient market hypothesis wouldn't allow a company as big as NVIDIA to be overvalued, because we have an efficient market, right? It doesn't allow overvaluation. But now I was arguing NVIDIA is overvalued. I was like blubbering something that I just heard other people say. Maybe I was looking at some metrics like PE, price earnings multiple or so, concluding it is overvalued, but not really doing like a free cash flow analysis, not really looking into the future, not really doing a deep dive in the valuation, or not. Basically, I still did all those things. I still saw it, but I still didn't invest in it because of this like limiting belief. I was just like, it was just a mental limiting belief. I was just telling it myself. I had no basis of assuming this. It was very superfluous, so very superficial, I should say. It was very superficial argument. It was not well researched. I was not honest to myself, right? This was not my honest opinion. I was just telling this myself, kind of like forcing it to myself. So this was, and you can see that I already saw, like, now I was much more confident. I had published 113 articles about NVIDIA over a multi-year period. So I was seeing NVIDIA very clearly, but I thought, okay, it might come down, and it actually did come down, right? It actually did come down. If you look at the stock, like from 200, it was like, let's have a 5-year outlook. Stock was like 200 USD, something here, right? Stock was here, and I thought, it will come back. It has already grown so much to 200. It will come back, And then it has this epic run to like 330, and it actually did come back. And here at like $100, I was also like even then I was considering it, and I saw that it had come back. But then like what I thought next is, yeah, maybe they don't have a big advantage. It's just a commodity business, right? But maybe like I didn't even include this third rejection here. And since then it has had another 9x. So I'm totally fine with it, right? I'm fine. I'm okay with missing opportunities. Everybody misses opportunities. There's always something better one could have done. And hindsight bias is very real, right? I mean, I have had a great run. I've seen a great compound annual growth rate with my personal portfolio, and it's like the blue line. It's great. It's much better like than say a yellow line that you cannot even see here in comparison. Good. So I've seen it, but I rejected it for different reasons. I was not true to myself. I was not seeing clearly. I think on a deeper level, I was not prepared to take the opportunity life throws at me, right? So because life always gives you opportunities, gives me opportunities, gives everyone opportunities. But sometimes people are just not ready to take them internally. So they still struggle with their confidence, for example. They still believe they are not worthy of taking the opportunities. So and their own like limiting beliefs limits them or prevents them from taking on the opportunities and like using them, because sometimes opportunities also seem too good to be true, so we reject them, even though in hindsight they are very obvious. And I think like having a bit having a focused life of clarity, a lot of walks in the forest and stuff, helps you like see the opportunities and also maybe build your mental capacity to prepare yourself for taking on these bigger opportunities. Okay, so still, but now like after all this episode, now NVIDIA at 800. Here, you can again, let's have a look at the stock price, 877. I must say, and this is difficult now for me, right, to do. I must say, nothing has changed. Data is still growing exponentially, right? The mass of data, the volume of data captured in the digital space, it is growing exponentially. It will probably grow 100x over the next decade or so. The data we are capturing. So we capture more data. Also, the model sizes are growing exponentially. So if you look at the AI models, here you can see this plot, like this is one plot. You can see like this is a log plot, right? So every time like each step on the y-axis is actually a 10x of the model size. You see how the model size explode. It's not even an exponential. So here in this a log linear plot, if you had a straight line, this would mean that you are growing exponentially, right? You 10x. So for each one step, or for each like one hop on the right, on the x-axis, you would get a 10x on the y-axis, which is like an exponential growth curve. But you see, it is growing even super exponentially. It's growing faster than exponentially. If you would like a regression line here, you would see, or regression curve here, you would see it would actually, the growth would accelerate. And why is that? Let's have a very quick excursion to the AI scaling laws. The AI scaling laws means that as you increase your compute, as you increase your data size, as you increase the number of parameters in your model, so your model size, the performance of your machine learning predictions also increase. They are not fading out. They are not converging. The performance is not converging. You can still get a significant leap in performance improvement by just throwing more compute, more data, and more parameters, more higher model sizes at the problem. Which means like each of those, the number of computations, the number of data items, the number of parameters in your models, each of them increase exponentially. So you have three forces increasing exponentially, and I have done like a very simple napkin math formula I've developed here. If you look at compute, this is basically the compute is proportional to the data we have times the model size. So if the data grows exponentially, say 10x, and the model size grows 10x, then the computations we need to do grow like by more than 100x. It's like even more than 100x, right? So it's like the growth of the computational demand is exploding, and we are nowhere near. How do I know that we are nowhere near? I know because of the AI scaling laws that are proven, right by first-class researchers, top researchers. We see it everywhere. We see it in self-driving. We see it in GPT, generative AI. We see it like in every single field in AI, that we just need to throw bigger and bigger data on bigger and bigger models, and we get better and better performance. And we will do it, right? Because the business value of this is so huge that it is just like we will throw more and more compute at it forever. It just means we are in the middle of a huge intelligence explosion, and it will just persist. So look at what NVDA is telling us, then, like in their own company reports. They ask the questions: why accelerated computing post Moore's law era? So Moore's law means like the cost of computation basically was dropping exponentially, so to say. Like, it is not like exactly the Moore's law. Let's maybe have a quick look. Moore's law is the observation that the number of transistors in an integrated circuit doubles about every 2 years, right? This basically means that we have a line here. It doubles every 2 years, which means that we have more and more chips. Like, this is the reason your smartphone is more powerful than the computer used for like the first space travel rocket ship or so, right? Like your smartphone, not only by a bit, but like a 1 million X or something like this, right? So Moore's law was the reason for this. But you see, Moore's law is fading out. So the progress in just raw CPU performance is actually decelerating. But NVIDIA is actually growing even faster than Moore's law, their GPU computing performance. It doubles every year. So in 10 years, we have a 1000x. Like 2 times 2 times 2 times 2, 2 to the power of 10 is 1024. So we have 1000x in 10 years. Now think about this. Think about the implications of this. This formula is one of the reasons for this, right? And the scaling laws, these are the fundamental forces. This formula, compute is proportional to data times model size, kind of, and both are exponentially increasing processes. You can see this is why we needed GPUs. And we need GPUs. Why GPUs? Because they are efficient in training these kind of models, because they are highly parallelizable. So the demand for GPUs, there is no saturation. It is the limiting resource. We will put intelligence everywhere. This is the infrastructure on which we are building our new societies. And these new societies, they won't look like the old societies. The new societies built on AI will look completely different. We will explode our world, the intelligence of our world, the awareness of our world will explode in every imaginable way. Energy consumption, everything will explode. And you can see the compound annual growth rate of the AI chip market between 22 and 27 was like 61%. These are crazy numbers for an industry. And and we are nowhere near like convergence, right? Even if you would consider a single model like text-to-text generative AI model, something like you chat with a chatbot, there are the scaling laws, like the AI scaling laws, applied to a text-to-text generative AI model, right? But what we still need to do is text to video, video to text. So we still need to process this kind of data. We are talking like a picture is worth 1,000 words, right? Video is worth 1,000 pictures, kind of. So we're talking about orders and orders of magnitude of future growth of data processing, of highly parallelizable data processing, because now you can analyze the frames independently from each other and so on. There are many ways you can parallelize video processing. So we have not even started. These models will be capable of processing whole videos. They will look like the models we see now will look very tiny compared to the models we will see in the future. The computational demand is virtually infinite. What we still need to do is develop 1 billion humanoid robots. In the recent keynote, NVDA keynote, Jensen Huang, the CEO of NVIDIA, actually presented the idea of providing a unifying platform for robotics training and inference that can be used by startups to easily develop and deploy humanoid robots. And we have startups such as Figure AI and so on that partner with NVIDIA, that use their platform to provide humanoid robots. Currently in the world we have, like, say, a few hundreds of thousands of humanoid robots, but eventually we will see billions of humanoid robots. We will see more humanoid robots than people. And we already see some companies such as Amazon or so where the number of robots has actually now exceeded the number of people working there. And we will just see it on a global scale in the not too far, not too distant future, right? We will see billions and billions of humanoid robots that all need AI training, that all need AI inference models in their own heads. So we need to train and create the models, we need to deploy the models in the robots, and the robots need to use inference to like do something with the models, right? To produce the raw intelligent behavior. So training and inference is in demand, to say the least. We are still working on self-driving cars, right? You can see the Tesla is purchasing NVIDIA chips on an exponentially growing demand curve. And but other companies also like use NVIDIA's self-driving vehicles platform to be able to also let their own cars drive. And the data those cars need to process is also huge. So the demand for chips will be massive, right? And like this formula, I always think about this formula. Look at this. We have an exponentially growing data sets. We have exponentially growing models, even super exponentially growing models, and the compute needed. Like if you have an exponential times an exponential, it of course remains like, I don't even know, like it's an exponential times an exponential, still an exponential, right? Yeah, because you have 2 to the power of x, say, plus, say, 2 to the power of x, or 3 to the power of x or something. It's just 2 to the power of x plus x, like roughly. So it remains an exponentially growing curve, but it is growing even faster. Like the slope of the exponentially growing curve is greater. Okay, so the valuation still needs to be done, but I think nothing has changed. NVIDIA is still a very attractive company. It might fall. I mean, we might see something like this here in 2022, where it falls from like, say, 400 to 200 and then just to grow to 800, right? I think it will keep growing, the stock price with volatility. But specifically, I still need to do a valuation. Before I provided you some valuation insights in Tesla and Alphabet, Google, and I will provide valuation for NVIDIA as well. If you want to get notified by this, then just hit subscribe, check out our channel, and check out my free email newsletter. Just go to finxter.com, finxter.com, and subscribe at any of the forms provided there. We provide a lot of free content, free weekly newsletters. My purpose in life is to help you stay on the right side of change, to help as many people as possible. We have already 160,000 people on our email newsletter, and like 99% of them enjoy it. The rest unsubscribes, I guess. And yeah, you can check it out for free. Just go to finxter.com. Also, if you want to check out our prompt engineering courses, we have great in-depth prompt engineering courses by experts, such as next level prompt engineering with AutoGen Studio, building generative AI apps with Google's Vertex AI and LangChain, fine-tuning OpenAI, how to create and scale your digital self. Like Dirk created an example, Chris GPT. And then the most recent course at the point of recording is building complex multi-agent teams and systems with LangGraph. And I really enjoyed this course. I think it's my preferred course, also recorded by Dirk and created by Dirk, because it, like, thinking about it, this is the future, right? Not creating a single agent is interesting. It's like making a baby, right? Making a baby is like beautiful experience. You create the baby, you put some intelligence into it over time, hopefully, and the baby is then a wonder on itself, right? But having like hundreds or thousands or millions of babies that grow up and that interact together, they build a society. And on a global scale, on a collective scale, the society solves problems that are orders of magnitude harder than the problems that can be solved by a single grown-up baby, by a single human being, right? And the same for agents, right? You as a person, as a one-person coding startup owner, maybe, as a person sitting on your computer, you can create a society of agents, of AI agents that works together. Each of those agents, they work together, they build something beautiful, they build like a whole new universe. They solve problems that you could never solve before with a single AI agent or even a single human being or even a group of human beings. You can create a company that is more powerful than Google, than Alphabet, than 100,000 coders working together. You can build a company that is more powerful, that creates more value to the world in your garage or at your desk, right? With using this kind of multi-agent setups, agent setups. And LangGraph is the way to do it. Okay, so I think this was a long video. Thanks for listening to the video. Thanks for giving me your attention. I hope you learned something out of it. My number one goal is to help you out, to give you more value than you give me in your time. Check out the Thingster Academy. You can just Google it to, for example, learn how to build multi-agent teams and systems. Check out our free email newsletter and subscribe to the channel to get notified maybe this week sometimes when I release my NVDA evaluation. Thanks for listening and see you in the next video. Bye.